Alright guys, so today is day 4 of Unit 5. Before we get into the lesson, I just wanted to go over last night's homework. You had questions 5 through 7 on day 1 of piecewise functions. So today we are still going to have the same essential question, what is a piecewise function and how do we graph it? So remember, the biggest thing to remember is we have two separate equations, two separate functions, and together they create a piecewise function. So the first thing that we talked about doing is we have multiple functions, but we can't graph them at the same time. So let's separate them. Okay, so this is what you would put into your calculator. So we'll say y1. Okay, and then because it is less than or equal to, that means it's going to be a closed dot. Okay, and it's less than. So we are going to take all the coordinates, okay, that are, that they go to the left. All right. And for the other part, okay, we have this part. So this is the coordinate that x is equal to 1. That is not going to be included, so we need to put an open circle there. Okay, and it's greater than, so we use any number that is greater than 1, but make sure you do include the number 1. Okay, to find what that coordinate is, you just put an open dot. Because remember, between 1 and 2, we have tons of numbers, right? We have 1.1, 1.00001, like we have a million questions, so, or a million points in there, because remember, a line is created of infinitely many points, coordinates. So we need to make sure that we include all of those points in our coordinate. All right, so the next one, sorry for all the mess, fix it. Okay, so again, we have our two functions. We're going to separate them into two separate functions and then piece them together. So again, x is greater than or equal to 0, so when x is 0, whatever that coordinate is, that's going to be closed circle, closed dot. And it's greater than, so we're going to go up, so it's going to go to the right. And then for the second part of our function, the second piece, okay, that's in the blue. Okay, x is less than 0. Don't forget to start at 0, but that's going to be an open dot. And then again, we go less than. So that one should go to the left. So this is what your graph should look like. Also, just if you notice, I did it in the last one as well. So this is g of x. That's the name of the function. Remember, I've been kind of going crazy. And when you guys get your quizzes back, you'll see that I took points off if you didn't label your graph. Okay, you always need to label your graph. Now with a piecewise function, you can get away with just writing a g of x because there's all of these different parts, and if you just label it 2x plus 3 and x plus 4, that's not really 100% accurate because you didn't graph the whole entire function. You're just graphing the part of the function that you need, the piece that you need. Okay, and then for number 7, that was a multiple choice question. As I was walking around, a lot of you were making the smart decision to cross off A and D, which I was very happy with. If you notice, these are all closed circles, right, at each of these endpoints right here. So if you look, all of these in A and D, all of these would be open circles. Okay, so A and D cannot be. Also, in addition to that, if you look at D, both of my slopes, because this would be a 1, right, both of them are positive. We can clearly see that this would be a negative slope and this is a positive slope. Okay, don't forget Mr. Slope Guy. All right, so it cannot be D for many reasons. Okay, and then lastly, we chose C because of this coordinate right here. So if you put y equals -1/2, okay, into your calculator, you would see that it has a coordinate of -4, 2. If you put -2x in, that does not work. Okay, so again, these are just different ways that you can double check for your multiple choice questions. All right, so getting into today's lesson, again, we are just going to continue with our essential question, what are piecewise functions and how do we graph them? Day 2. So before we get started in doing a couple more graphs, we are going to write our own equation for a piecewise function. Okay, so a lot of this is all ridiculous notation. That word again, I know I always talk about notation. A lot of things in algebra, guys, if you just pay attention to learning the notation, it really a lot of times is not that difficult. It's just the notation. Use that word again. Okay, so I'm going to have two functions. I'll make one red and one blue. Before I even write the equation, I'm going to do my domain. So notice that this is a closed dot right here, okay? And that's when x is 0. So if x, now it goes to the right. So the nice thing about this is our inequality symbols go the direction that we want. So think of that as an arrow, like the head of an arrow, right? So that points to the right, so that is going to be greater than. It's equal to because the dot is closed. So before we even write the equation, I'm actually going to just write my other domain. So if, now this one goes to the left, but it's also, obviously it's the same point, so when x is less than or equal to 0. So both of these are going to be greater than or equal to, and then a less than or equal to. And again, this, a little dot in the middle in blue, so you know it's the same point. And then this one goes this way. Okay, so for both of them, b is actually equal to 2. Okay, so remember our original, I'll do this. Okay, so you know both of them are equal to 2. Okay, so all I'm doing is I'm writing this into y equals mx plus b. I see that they are both lines, so I'm going to write y equals mx plus b. So let's do the top one first, the red. So what I notice is that we go up 2 and right 1. So m is equal to 2 over 1. So 2x plus 2 is my first line. And for this one, I see that going up 1 and over 1. So m is equal to 1 over 1, which is just 1. So x plus 2. And that's all. That's all you do. Okay? So you figure out what the lines are, and then you write their domain, or vice versa. All right, so for today's questions, we're going to do a couple word problems. And then I did include one that has an absolute value, but what I want you to pay close attention to is our domain. So now we're getting very, very specific. Okay? So I have the absolute value of x, and then I have f of x is equal to 4. So I'm actually going to do that one first. So f of x is equal to 4. That's just going to be the line. It's going to be a horizontal line, right? And we are going from 1. So, okay, we are going from 1 all the way to 8. 8. Okay. At 1, so this is going to be a closed dot, and at 8, it's going to be a closed dot as well. And all of these are 4s. Okay. Because it is a horizontal line. Okay. And again, if you want to graph that in your calculator, you can. 1, 2, 3, 4. Over to 1. So we're going to have an open circle here. Sorry, closed dot. dot here, all the way over. Okay. All right. Now the next one, for our absolute value, okay, so I have f of x is equal to the absolute value of x. So this one, I'm starting at -3, and I'm going to go all the way up to 1. Now again, it's being very specific. So at the coordinate 1, I'm going to have a open circle because it's less than, and then here I'm going to have a closed circle. So if you put this into your calculator, you would see this is just 3, 2, 1, 0, 1. So again, I only want these points. I only want this coordinate because it gave me the domain. Okay, so we have at 1, 1, we have an open dot, dot here, dot, 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 and that's where we end. Okay, so I'm going to just this line. Okay, notice I did not put an arrow. No arrow. This does not go on forever, so do not put an arrow. Okay, so for number 2, 2, 3, and 4 actually, we are going to talk about how we would use a piecewise function in an actual word problem. Okay, so a big thing about this, a lot of what it says in here is really just confusing. Okay, they give this to you. Okay, so read what the question is asking, but they gave you all of the information right here. Okay, so I know that this looks pretty big and scary and whatever, but it's really not as complicated as it seems. Okay, so we have our 2 functions, so really just put those in your calculator and get these tables. Okay, the next thing to do, the only reason why it is important to read the question is because we're talking about purchasing pencils. Okay, so if you look, okay, the X's represent pencils. Okay, so this is going to be all whole numbers. Okay, so do not connect the points. Okay, this is called a discrete graph, which means that they're just going to be a bunch of dots. So all you're doing is you're plotting these coordinates. Okay, the domain said for the first one, you're going to go. So again, the domain, our x values, that is how we figure out what points to use, what coordinates. Okay, so this is saying that we're going from 0 to 9, okay, for the pink part. All of these are open dots. And really you're just going to go till you get to the end of the graph. That's how you figure out how far to go for this side. So it says x is greater than or equal to 10. So again, all closed dots. Okay, we have all of our greater than or equal to signs. All right, so then the next part you're going to do is you are going to answer the question. All right, so you use your graph. Again, this really is not that hard of a question. The harder part is to figure out, get through all of the actual words of it and then just answer the question. So a customer brings 8 pencils to the cashier. The cashier suggests that the total cost to purchase 10 pencils will be less expensive. So state whether the cashier is incorrect. And we're going to justify our answer. So remember, justify, usually this means to do it with math. But again, you really gotta look through the question. You're not just gonna be able to justify this with math. You're gonna have to write a little bit of a sentence. So 8 pencils cost $14, and 10 pencils cost $12.50. You literally get that right from the graph. Okay. So this would be 8 and 10. So you can clearly see that it's lower. All right. This would be for 10. Again, you can look right here as well. And where's 8? 8 is right here. Okay. So again, nowhere does this say to make a table. All right, but it says to justify. So make a table. Make tables. Okay. Also, you have to include the answer to your question. You have to say the cashier is correct. You have to write that. All right, and then 10 pencils is less expensive than 8 pencils, of course. Okay, so just make sure that you get all the points necessary. I really would hate for you to do all of this work right and then not say that the cashier is correct, so we have to take off points. All right, for this next question, I want you to notice everything that I underlined, okay? So during a snowstorm, a meteorologist tracks the amount of accumulating snow. Oh, can't wait for our snow to be gone. For the first 3 hours of the storm, okay, so that's important. Anytime you see any numbers, you want to underline that. For the first 3 hours of the storm, the snow fell at a constant rate. Whenever you see the word constant, that is linear, of 1 inch per hour. The storm then stopped for 2 hours and then started again at a constant linear rate, of course, of 1/2 inch per hour for the next 4 hours. So we want to draw and label a graph. Please, please, please label. Okay, you guys have to label. Also, it says to, so if you don't, points off. That models the accumulation of snow over time using the data. Okay, so you're literally just going to make your graph based on the information. Okay, so the first part says, so of course we start out with no snow. So for the first 3 hours, okay, the snow fell at a constant rate of 1 inch per hour. Okay, so it's going up by 1, up by 1, up by 1. Okay, then for let's see, for 2 hours it stopped. So no snow. That would be a flat line. Okay. Then for the next 4 hours it goes up by 1/2 inch. So you're gonna go. So you're gonna go up 1/2 and then over 1, up 1/2 over 1, up 1/2 over 1, up 1/2, and etc. Okay, so you're gonna go all the way over until we get to 9 hours. Okay, so if you do that, so we have 3 hours.
Good morning. If you are driving.
2 hours, and then 4 hours. So that's a total of 9 hours. So that's where it's going to stop, right? So then we got to answer a question. Okay, so if the snow started at 6 p.m., how much snow was accumulated by midnight? Okay, so literally you just do a little bit of subtraction, and then you're going to go at the 6-hour mark. Okay, and that is at 3.5. Easy as that. All right, now for the last question. I know I'm going to bring this question up again at the end of the year as a review because it is a great review question for piecewise functions. Okay. So the equation to determine the weekly earnings of an employee at the Hamburger shack is given by W of X, where X is the number of hours worked. Okay. So the biggest thing about this is understanding what it says. Okay. So we need to determine the difference in salary in dollars for an employee who works 52 hours, okay, versus one who works 38. So basically, all this is showing you, okay, is if, so you use this function if you work 40 hours or less, okay? So you use this equation if you're working 40 hours or less. If you work more than 40 hours, so 40 hours, you still use the top function, okay? But if it's greater than 40 hours, this one, now anybody who has a job or understands how you get paid for a job, if you work more than the hours you're supposed to, you get overtime, okay? So this is the equation if you work more than 40 hours, okay? So all you're going to do is you're going to plug these in. So when when x is 52, we use that pink equation, okay? So you'd get $580. If you work 38 hours, you would use the blue equation, okay? So you're basically you get $10 an hour, so you're multiplying it by 10, so you'd get 380 hours. Difference, of course, means subtraction, so your final answer would be $200 difference. Okay, that should be a nice, easy set of points for you. All right, now the next part is a little bit trickier. Okay, so we want to determine the number of hours an employee must work in order to get $445. Explain how you arrived at the answer. Well, the first thing I noticed is if I plug in the biggest number, so for, let's see, so if we use the function w of x is equal to 10x, the largest number you can do is you can only work 40 hours, right? So if we plug that in, that would only equal $400. So the maximum amount, $400. Okay, the maximum hours I could work will be 40 hours from that first one, and sorry, not hours. I would get $400. Okay. Well, I need to get more than that. So that means that I'm definitely working more than 40 hours. So now what I'm going to do is I already know I'm going to use the second equation. All right. So instead of finding what the w of x is or what the money is, I'm going to actually substitute that in, and I'm going to solve for x. Okay. So again, this means to distribute. So I distributed to get 15x minus 600 plus 400. Okay, combine like terms, and I get that x is equal to 43 hours. So since w of x is greater than 400, x must be greater than 40. Therefore, we substituted 445 for w of x and solved, solve for x to get 43 hours. This says explain, so write a